This video is to show you how to solve the system of equations using your Ti83s. So the first question here is determine if the ordered pair 7, 6 is a solution for the two equations. So when they ask you to find out if that is a solution, they're asking you to check if that is a point of intersection. Okay, so how do you put it in? When you're putting it in your calculator, you gotta put it in terms of y. So first you're gonna solve for y here. For the first equation, y for the second equation. You don't have to go ahead and simplify it. You can just solve it the way it is and you can just put it in. So I'm going to go ahead and put in the first equation. Y is equal to parentheses -4 minus 2x close parentheses over 3. The next one is 4 minus 2x. And I'm going to go ahead and graph it. And I see that there is a point of intersection, but how do I find it? Second, trace, going all the way down to 5, enter. First curve, see that the dot is on the first curve, and that is the first curve, enter. Now the blinking part goes to the second curve, enter. Guess, enter. So the point of intersection is 4 and -4, not 7 and 6. So this is false. So 7 and 6 is not a solution. Now if I have to go ahead and check for the second problem here, I'm going to go ahead and clear this. I'm trying to see if 2, 3 is a solution. That is, in the other words, I'm trying to see if the point 2, 3 is a point of intersection. So how do I do? I'm going to go ahead and put it in the calculator. But remember, you have to first find y by itself. So the first equation would be y is equal to 11 minus x over 3. The second equation would be -13 minus x over -5. So I'm going to go ahead and put that in. Parentheses 11 minus x, close parentheses, divided by 3. And open parentheses, -13 minus x divided by -5, and I graph it, and I see that there is a point of intersection. So second, trace, 5, first curve, enter, second curve, enter, guess, enter. And the point of intersection is 2 and 3, and that is true. So 2, 3 is a solution and is a point of intersection. So we're going ahead and solving this problem by substitution method, but I'm going to go ahead and show it to you how to plug it into your calculators and then find the point of intersection. Remember, every time you plug in, you have to make sure y is by itself. So the first equation would be y is equal to parentheses 4 minus 3x divided by 2. The next one would be 1 minus 2x. When I graph it, I do see there is a point of intersection. Second, trace, 5, first curve, enter, second curve, enter, guess, enter. And the point of intersection in this case is -2 and 5. If I'm trying to solve this equation, and again y has to be by itself, so the first equation would be the x plus y is equal to 4 now becomes y is equal to 4 minus x. So y is equal to 4 minus x, first equation, y is equal to 3x, next equation, graph it. Yes, I do see a point of intersection. Second, trace, 5, first curve, enter, second curve, enter, guess, enter, and the point of intersection is 1, 3. They asked me to solve the system of equation by addition method. I'm going to go ahead and put it in the calculator. Remember, when you put it in, y has to be by itself. So I solved the first and second equations to get y by itself. So that is going to be parentheses 3 minus 4x, close parentheses, divided by 5, first equation. Next equation, open parentheses, 7 minus 2x, close parentheses, divided by negative 3. Graph it. Yes, I do see a point of intersection. Second, trace 5. First curve, enter. Second curve, enter. Guess, enter. Point of intersection is 2, negative 1. Now let's go ahead and look at the other problem. In this one, let me go ahead and clear this. Clear. And again, 3x minus 4y, 2x plus 3y, I can't put them in the way they are. They have to be in parentheses, so it doesn't matter where you put the first one or the second one. 11 minus 3x divided by negative 4, first equation. Second equation, parentheses, negative 4 minus 2x, close parentheses, divided by 3. Graph. Yes, I do see a point of intersection. So second, trace 5, first curve, enter. Second curve, enter. Guess, enter. 1, negative 2 is a point of intersection. So if I solve this system of equations here, and again, I need to make sure y is by itself. The first one is parentheses 4 minus 5x, close parentheses, divided by negative 2. And the other one is open parentheses 7 plus 10x, close parentheses, divided by 4, and graph it. That's my first line. That's my second line. When I look at the lines, they are parallel, so they will not be having a point of intersection. But let me go ahead and find one just in case. I want to see what the calculator would give us. 5, first curve, enter. Second curve, enter. Guess, enter. Quit. That means there is no point of intersections. All right. So same thing as with the second one. Let me go ahead and show you this problem here. So this one would be, I'm going to go ahead and plug it in, clear the previous ones. This would be parentheses x minus 9, close parentheses, divided by negative 2. And 13 minus x, close parentheses, divided by 2. Graph. Lines are parallel, so there is no point of intersection. So if I want to go ahead and graph these, solve this system of equations, the y is already solved for me. Y is equal to x plus 8 divided by 4. Second equation, negative 40 minus 5x, close parentheses, divided by negative 20. Graph it. So I see that it's the same line on top of the other. So this is a dependent system. So in this case, the system is just dependent system, and the solution would be the set of x, y that satisfy any of these equations. So let's go ahead and look at the next one as well. So this is again a system of equation. I have to solve it. So y has to be by itself. And again, so I'm going to go ahead. Y is equal to 3x minus 5. First equation. Next equation is 21. X minus 35. Close parentheses, divided by 7. Graph it. When I look at the graph, again, it's the same line on top of the other, so the system is dependent. So it's a dependent system. So technically, any values of x and y that satisfy the first condition will also satisfy the second equation. So that technically I'm saying that the solution set is x and y that satisfies the first condition. The same is the solution for the second condition. So whatever values that satisfy the first equation should also satisfy the second equation. If you go ahead and look at the table, you see that when x is 1, y is 2. The same thing. When x is 1, y is 2. So whatever is the x value here, the same y value is here, and for y2 as well. Hope this is helpful.